All right, let's talk about synthesis. This is going to go through and introduce a basic model for modular synthesizing. So we'll start with the definitions. Sampling is focused on playing back stored audio via MIDI on a sampler, what we've already done. It's commonly used in film scoring to substitute for instruments or an orchestra, and you can use low-frequency oscillators and round-robin sampling to make it more or less realistic. Synthesis, however, is creating a sound from scratch using an algorithm or a recipe. It can recreate traditional sounds to an extent, but it's usually used for creating new timbres. Analog synths are physical hardware synthesizers. Analog modeling, however, does not require physical hardware. That is using a soft synth based on a modular approach where every unit has a specific function. Multiple modules are strung together and connected to form a synthesizer patch or recipe. So the abbreviations you're going to see quite a bit. VC anything stands for voltage control. This is commonly used in analog synthesis and analog modeling to show that the object is receiving voltage and not generating voltage. DC stands for digital control. It's rarely used as most digital modules are still receiving voltage for control purpose, but you might see it. LF stands for low frequency. This is commonly used to describe modules that operate below the range of human hearing, so generally slightly above 0 to around 23 hertz. This is almost always going to occur in the form of a LFO or low frequency oscillator. Then you have envelope types like AD, AR, and ADSR. If you need a refresher on those, go back to week 3. At its most basic, the way that a synthesizer works is that it takes input from an input device. It passes that input to an oscillator in the form of a volts per octave signal, and it sends a gate signal to open the envelope generator and to sustain it until you release a key. The waveform from the oscillator is passed to a filter, and the sound is shaped to remove unwanted partials either above the note or to remove the fundamental and just get the partials, or to do other shaping. The filter output is passed to an amplifier to boost the signal before then being sent to the final output. Here we have a screenshot that shows exactly that. On the left, I have MIDI to CV. That is taking MIDI data from my computer, exporting it out of the volts per octave output into the volts per octave input of the VCO. The SAW output of the VCO goes to the input of my voltage controlled filter. The low pass output of the filter goes to my mixer. The output of my mixer goes to the audio interface. But at the same time, the gate signal from MIDI to CV is being sent to the ADSR envelope, which triggers the envelope. The envelope output is being used in two ways. I've got two cables stacked there. One opens up the filter frequency and moves that from 0 to something within the audible range. And another copy is going into the volume level on the mixer. So that mixer is functioning as my amplifier. When the ADSR is silent, nothing is coming out of the mixer, even though it still is receiving the signal from the oscillator and the filter. However, when I trigger the envelope generator with a gate, it opens up the mixer to its maximum amplitude, comes back down to a sustain level, and then when I release a key, it dissipates back into silence. And all of that is output to audio channels 1 and 2, which are my left and right stereo channel. So, let's talk about the parts of the synthesizer. These are going to be modules, and every module is going to be its own separate set of functions. It does a single task, it does it really well, and then it passes its output, and you can route those with cables to other modules. For this, we're going to be using VCV Rack. It has the benefit of being free and relatively easy to use. So I'm going to go primarily through the modules that they use as part of the fundamentals set. There are hundreds and at this point thousands of modules that you can download for free that go into VCV and will have different functions for different oscillators, different LFOs, different envelope types, low pass gates, effects, all of that. But I'm just going to stick with the basics. You can explore the rest on your own, and I strongly encourage you to do so. So the most important thing to have at first is the MIDI to CV converter. It takes the input from a MIDI controller from your computer's keyboard or an attached gamepad and outputs it as CV signals so you can control all the other modules. If you click the 3 lines of text, you can change the options for the driver, the device, and the channel that it's receiving on, respectively. This is very important because by default, it probably is not receiving anything. The outputs, volts per octave is going to be pitch for an oscillator. Gate is a trigger that stays on until you release the key. Velocity will be velocity values. Aft is aftertouch. PW is an important one. That is the pitch bend wheel. MW is another important one. That is the modulation wheel on your keyboard. And retrig, RTRG, is retrigger. This one's really useful to reset the sync of an oscillator or an envelope if you're playing really, really fast stuff. It might have a release phase that's going to take a little bit of time to close. This will automatically close it and jump back to the attack if it is taking a retrigger in. Next is the VCO, the voltage controlled oscillator. This is your main source for pitch and timbre in a synth before it gets shaped by the filter. It produces a number of basic waveforms like sine, triangle, saw, and square, or PWM. All of those are output in the black boxes at the bottom. For the controls, it takes a volts per octave input, which takes the voltage from whatever input device or sequencer, and uses it to generate pitch in relation to the frequency knob's position. So the frequency knob is your basic coarse tuner. You also have a fine knob that allows you to do fine-tuning adjustments of that. So if you really want to dial it in and make sure that it's perfectly in tune with the oboe in the orchestra, you can do that. PWM in controls the offset of the pulse width. Remember, it's a square if it's at 50%, but it also can be modulated. If you turn up the PWM CV control, that will affect what's getting sent to the pulse width knob, and you'll be able to morph between, say, different duty cycles, and you'll have some very nice sweepy timbral effects. Finally, sync resets the phase of the waveform to 0 when triggered. Again, if you're playing a lot of really fast stuff, I recommend having that synced up and having a retrigger going into the sync. Noise is a noise generator. It just outputs noise. There are no inputs. Now, the types of noise are connected to their outputs. White noise is pure randomness. Pink noise is equal power across the octaves. Red noise is pink noise, but with a steeper roll-off. So that's going to be even more bass heavy. Blue noise is with the power increasing by 3 decibels per octave. So that's going to be the inversion of red noise. Violet noise is the power increasing by 6 dB per octave, which will be effectively inverted pink noise. Gray noise is random noise subjected to a psychoacoustic equal loudness curve. So it equalizes the low frequencies so that you hear them at the same frequency as the higher frequencies. Black noise has a lot of different definitions depending on who's implementing it. In this case, it is gray noise with a slight bias towards the higher register. On digital modules, it is a word clock quantizing error that can sound very glitchy and very, very cool. VCF is your voltage-controlled filter. This is where you're going to put the sound in the input, and it will shape it by removing frequencies from that input signal. It outputs either a low pass from LPF or high pass from high PF. And yes, you can output both simultaneously. The controls are frequency, which controls the cutoff frequency and can be fine-tuned with fine. It also can take voltage to freak with the freak CV knob, controlling the depth of how much it will modulate that frequency to either side. Res is the resolution or Q of the filter. Remember that the higher the resolution, the steeper the cutoff after the cutoff frequency, but right at the cutoff frequency, you'll have a boost and you'll potentially create a whistling effect. Drive controls the amplification of the filter and can be used if you have a really quiet sound to amp that up just a little bit. There are many, many, many other types of filters, particularly in VCV Rack. I encourage you to use the search feature to explore a couple of those. Moving on, we have the VCA, the voltage controlled amplifier. All this does is it takes a signal at the input and it boosts it according to the level setting and outputs the result. The level will go all the way from completely off to max amplitude. For controls, it requires an envelope signal from an envelope generator to open, decay, sustain, and close the amplifier. There are two inputs for those envelopes. You have EXP, which is an exponential response curve, which will sound a little bit closer to how humans actually hear things. Lin is a linear response curve, which is very, very useful for a lot of situations. Both will accept any valid envelope signal. And all of the calculations are done in the module itself. Also note that you have two voltage-controlled amplifiers in one module. There's one on top and one on bottom. The mixer is an alternate version of the VCA. It lets you mix 4 signals together, and you can output them individually from the channel 1, 2, 3, and 4 outputs, or you can output the global mix of those signals. So level controls the global output volume for the mix, and that can be controlled easily with an envelope into its adjusted CV input. Each individual fader controls the volume of that specific channel, and they all have their own associated CV in, which will accept any envelope signal and can get you some really, really cool effects if you're modulating and have delayed envelopes or different stage envelopes, and then it creates some really cool effects. The ADSR is the envelope generator. It creates the classic attack, decay, sustain, release envelope whenever the module receives a gate signal from the input device. Retrig restarts the envelope instantly. This is super useful if you're playing really fast passages and you don't want to wait for the envelope to finish the release phase. It outputs the envelope signal to be used in any way you see fit. In addition to using it for the VCA, you can also use it to set the frequency of the voltage-controlled filter or to adjust the fine knob on your oscillator. It can be very cool to do that for some crazy swoopy pitch bendy stuff. All the controls for the ADSR have CV ins and can be modulated using another ADSR or a low-frequency oscillator or any other type of control voltage. Attack is the time to ramp up to the max volume when a gate signal is received. Decay controls how long it takes to ramp to the sustain level. Sustain is the percentage of the max volume that the envelope stays at until you release the key, and release is how long it takes for the sound to die away when you release that key and the gate closes. There are a couple of built-in effects in the fundamental series. The most notable is delay. It's just a delay that's applied to an input signal, and then it is output with delay. It is essential for fattening a signal that you're playing. Especially with synthesizers, you will note that mono synths sound very, very thin. I recommend using a lot of delay and being very judicious with the time and the mix control. Time controls the length of the delay. Feedback controls feedback, but do not leave it all the way right. It will be bad. Color shapes the color of the delay through internal filtering, but there's not really a way to access that. And mix, of course, is the dry-wet mix. So after you've created a synth patch, you need to get this out to your sound card eventually and be able to hear it. To do that, you use Audio 8. This is an 8-channel audio input and output, but you'll probably only be using it to use the to device part and not the from device. To device takes input from other modules and outputs it to a device, usually your speakers. From device takes audio from something else, like your interface, and outputs that into VCV Rack. So you are probably only going to be using to device, and you're probably only going to be using the to device 1 and 2 channels, unless you do have a multi-channel interface with all of the appropriate speakers hooked up. You have 3 lines of text there, and if you click on those, you can change the driver, the output device, the sample rate, and the block size on those respective lines. Another cool one that is now included is record. This is an audio recorder, and it's really essential for recording your performances in VCV so that you can use them in other programs. You just connect copies of your main, left, and right sounds to L or mono and right. I recommend just copying them on top of the cables that are going to the channel 1 and channel 2 in your 2 device on Audio 8. Then play a bit and make sure you're not clipping, and set the record knob to something appropriate for volume. Then for the controls, if you click the large button, it opens a save file dialog. You just give it a name and format, so audiofile.wave, and start recording. And it will use the sample rate set by your Audio 8 device. If you send a signal to gate, it will record only as long as the gate is open. Something like that I recommend using with a foot controller. You can set that so that your sustain pedal will open a gate when you press it down. We'll talk about that in modulation. That can be very useful. Otherwise, if it's mapped to your keyboard, you're going to get one file for every note, which might not be great. If you send a signal to the trigger input, it will trigger recording to start, and then sending a second signal to trigger will stop recording. This can be a little bit more useful, but you will have to think about how you'll set that up so that it will only record the segment that you want. Next up is the scope. This is an oscilloscope, and it gives you a visual of the waveform received in the X and Y inputs. The controls, you have X and Y scale, which control the overall scale or height of the waveform that's being displayed. X and Y position controls the location of where the waveforms will display. Time controls the length of time displayed in each frame. So if you need to zoom in and take a look at a finer part of a really fast-moving waveform, adjust your time and you might be able to see that. X divided by Y or X plus Y controls display mode. It will show either wave or phase. This can be very useful if you're noticing a bass cutoff. You can check and make sure that it's in phase or not. Finally, trigger controls the internal rate of triggering. Just leave that alone. Leave it set to internal. Don't mess with it. So there are some conventions and signal types that we need to talk about. And I'm definitely going to be demoing all of this in class, but just be aware, cable colors are randomized in VCV Rack. They do not correspond to signal type. There is no difference between audio and CV cables. In fact, you can patch audio into CV and vice versa. However, what they're going into is important. Again, volts per octave controls the pitch in modular systems. Gate output will generate a pulse similar to a square wave. It goes high when triggered, sustains until it's released, and then immediately dies back to zero. You can use this for envelopes or sustained controls that have to stay open. Triggers and re-triggers are one-shots. It's like a gate signal that immediately dies after triggering with no sustain. So that's really good for one-shot devices or for controlling clocked sources, which we'll definitely talk about. Clock signals are repeated trigger pulses that occur at a set interval and are used to control the timing of a sequencer, oscillator synchronization, or any other repeating event, like a clock modulator. They can be used in place of gate or trigger signals to control timed sequences, but you might have to adjust things like attack and decay in order to make sure that they don't get too long or that you hear clipping. They can also be used to glitch signals in interesting ways. Next are CC signals that are CV signals mapped to MIDI CC values. We'll look at those shortly, but they are insanely useful because using those will allow you to map out your physical knobs and faders on a MIDI controller to things in VCV Rack. By default, all modules in VCV can be reset to their initial state by right-clicking and selecting Initialize. All modules can be randomized from the right-click menu as well. Under the VCV menu, there's the View menu, and in there is a really useful option called Lock Modules. This prevents accidentally dragging a module if you meant to drag a cable. I really recommend using this a lot. Also, cables are infinitely stackable. You do not need a multiplier device. What you do is, if you've got a cable plugged in already and you want to add a cable on top, just hold Control on Windows or Command on Mac and click on that jack and it will create a new cable stacked on top. Or you can just connect on top by dragging a cable on top of another existing cable. MIDI to CV has the ability to switch to polyphonic mode, but be wary of that. Not all modules are polyphonic. Stick with mono unless you're 100% sure that all your modules are poly. That said, all of the modules in Fundamental are polyphonic. So with this, you're going to want to do a lot of practicing. I recommend you start experimenting immediately. You might not like the results at first, but it's important to start playing because this is going to involve a lot of experimentation. I've put a fundamentals patch on the website that includes the basic built-in modules just in a nice, good starting configuration with no cables. But to get more practice with the building blocks of synths, I do recommend going to Ableton's Learning Synth web app. This will just run in your browser. You don't need to download Ableton or anything, but it's a really nice tutorial on basic synthesis concepts. They have excellent examples of oscillators, filters, envelopes, LFOs, etc., and attempt to recreate some of their recipes in VCV. We will definitely be looking at these more in depth in the next couple of weeks, but definitely start playing on your own as well.